This is Professor Nina, and I'm back with another instance of Desmos. In this particular activity, we're going to find the difference of two proportions. So we're going to be focusing on finding a CI and finding a test statistic. Once we find a test statistic, we'll also calculate a p-value from that determination. We have a large school district which is considering changing starting times in its school. The change would involve a high school starting later than an elementary school. The school district was curious if parents support the change, so they surveyed separate random samples of parents from both the high school and the elementary school. The school district wants these results to carry out a two-sample z-test to determine if the proportion of parents who support the change is significantly different for each type of school. So we're comparing the difference in the two schools. Assume that all conditions have been met. So remember now, if H sub O is true, then the p-value of the high school will be exactly equal to the p-value of the elementary. It doesn't say one more so than the other, so the alternative to that would be that the p of the high school is not equal to the p-value of the elementary. And by p-value, I'm talking about the proportional value. So we're going to go find our test statistics first, and we'll deal with the high school. So the high school p-hat value, there are 54 people who responded out of 100 for a 0.54 statistical value. For the elementary calculation, there were 24 out of 50, which would be 0.48. First thing we'll do is we'll calculate a z-score. But in order to calculate a z-score, we're going to need a pooled proportion for a z-score. A z-score has a pooled proportion in 4 places. Everywhere in the denominator that has a p-hat without a sub 1 or sub 2 on it is a pooled proportion. In order to calculate that pooled proportion, we take the n value of the first, 100. We multiply it by the p-hat value, or the 0.54 of that condition. We add it to the second population of 50 times their percentile of 0.48. And then we divide the entire thing by the sum of the two groups, which for us is 100 plus 50. Go to Desmos and put that calculation in. I'll show you what mine looks like. And you can see here that I took 0.54 times 100. I added it to 0.48 times 50. I used an asterisk for the multiplication. I divided that by the sum of 100 plus 50, and I got a pooled proportion value of 0.52. So my p-hat pooled proportion, and I'm going to write pooled for you so you know that's what we just found, is 0.52. We're going to insert that calculation into the z formula. Our z formula is p-hat 1. P-hat 1 is 0.54 minus p-hat 2, which is 0.48. Don't confuse these with the pooled proportions. Minus 0. I then need to include the pooled proportion calculation underneath of the root. So my pooled proportion is going to be 0.52 times 1 minus 0.52 divided by the first n value, which is 100. I'm going to repeat that process on the other portion here, but I'm going to use the second p-value of 0.48, using the second codal of 48. I almost wrote it in the wrong spot there. This is the pooled proportion again, 0.52, times 1 minus 0.52. And here comes the second n value that I wanted in the first value, which was 50. This will calculate for us a z-score. Now, it's a very large formula, but it just takes a little bit of practice and time putting it into Desmos, and I'll show you exactly where mine lies. Oops, didn't stick it in there yet. So I'm going to make that calculation for you right now. So we're going to take the p-hat value, or calculate the z-score. Now, I have to get a couple of things going on here. So first of all, I'm going to protect my 0.54 minus my 0.48 in a set of parentheses, like so. Now, watch what happens if I hit division. We've talked about this before. I need to have all of this in division. So I'm going to put the 0 and the 0.54 in what we'll call a closed set of parentheses, so that when I divide, I now get a fraction. That gives me the entire numerator into the fraction position. I need a square root here. You can get it down at the bottom right here, or you can type SQRT. So I need 0.52, but now I want to multiply that by 1 minus 0.52. Now, because I have a parenthesis right there, when I hit the division, it's going to let me enter the 100. I scoot over. I make sure I stay under the root when I'm doing that. I hit the plus sign, and you can see the root keeps extending itself. Now, I want the same thing, so watch what I'm going to do. I'm going to go in here, and I'm going to copy this thing. I'm going to stay right over here, and I'm going to hit paste. And then I'm just going to go in here, I'm going to change this value right here to 50. When I do that, I get 0.693. Right there is my z value for my statistic. So I have calculated a z-score of 0.693. Now remember, that's a z-score, but I still need a p-value from here. If we think about that on a curve, here's a 0, here's a 1. I'm about right here. And remember, I'm calculating the area, which is as extreme as at 0.693. So I want to calculate a p-value based on an area that goes from 0.693 and goes to infinity. And we're distributing on a 0 and a 1 because all standard normal or z-scores come from a 0 and a 1. So I'm going to go back to my calculator. I'm now going to bring up the function of a distribution, normal. I'm going to put a 0, 1 in there even though I don't have to. Just like to see that. I'm going to include area. I know that my minimum score is 0.693. I know I'm going out to infinity, and I've got 0.244 for my p-value. Very large, very insignificant. So I have a p-value which is equal to 0.244. We will definitely fail to reject at any alpha level. It doesn't matter because that's so insignificant. It's so large. Now, the only thing we have left to do here is to calculate a confidence interval level for this difference of proportions. So using the secondary formula, we have to, first of all, I have to pick a confidence interval level. So I'm going to go with the 95%. We've used that in the past, and we've used it quite often in here. And remember that the z-score, if you go back to your formula sheet, your z confidence level at 95% is 1.96. Comes from right there. So we'll put a 1.96 in there for our z critical, also known as our z cret. So we need to make this fairly large formula for my confidence interval level. So I'm going to take p hat 1, 0.54. I'm going to subtract p hat 2, 0.48. That's in a set of parentheses. I have a plus and I have a minus, and I have a z star at 1.96. I'm going to multiply that by p hat 1, which is 0.54, times 1 minus 0.54, divided by 100. That's then going to get added to the second p hat value of 0.48 times 1 minus 0.48 divided by 50. There are two calculations here, one plus and one minus. So when I go to Desmos again, I actually have these open for you in a couple spots. I have them here. And I'm going to get rid of some other things down here and make them go away for right now. So I did the first one with the negative, 0.54 minus 0.48 plus 1.96, the root of 0.54 times 1 minus 0.54 divided by the 100. And then I'll stretch this out so you can see all of it. I did the 0.48 multiplied by 1 minus 0.48, and then I got 229. Now, I'm going to show you something kind of cool, and maybe you want to do this or maybe you don't, and watch, I'll get rid of this. So I will need the second one. So all I do is I just highlight the entire thing. I go down here and I hit paste, Control V, and I just come into here and I make a change. So one of these is going to be negative and one of these will be positive. So if I make this the negative one and this the positive one between the 196, I get my two CI values. Pretty sweet, I know. So the CI value for this instance will be between negative 0.109 and 0.229. We weren't asked for that, but it's nice to review how to get that value. When we come back, we'll work on a single mean and we'll work on the difference of two means.